Hey kids, let's do some more integration, right? Multiple integrals. So take a look at these two integrals and tell me what you think about had I asked you to evaluate, right? Can you see with u substitution? This one is nice, right? U is equal to x squared, du is equal to 2x dx. So I can completely replace this integrand with u du. And I can integrate, oops, sorry, this is u, sine u du. And I can either integrate this and replace, or remember these are x numbers. I can say what is u of 1 and what is u of 0. In this case, they turned out to be the same. And then I can integrate this, right? Oops, forgot my 1/2. So I would get 1/2 cosine u from 0 to 1, blah, 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 right? Do you see the issue here? Right, u substitution is not going to work. Sine it, I'm not sure what to do here. This is a problem. But I want you to recognize that what made the difference was having this x out here, right? Because u was x squared. Remember, that's not sine x squared, that's sine x squared. So look at this one now. I'm going to make a correlation now to Calc 3 or MVC, right? Look at this problem. This problem is asking me to integrate, and I've just got sine of y squared. Now remember what these represent. This represents in the xy plane, right? Since your y is on the interior limits of integration are y functions, and since your x is on the outside, these constants here are x constants, right? This is some surface on z space, but I can graph this, right? From 0 to 1, y goes to 1, and y is equal to x, right? So I have this region, and what strips have I drawn? The way this is set up, what strips are being drawn, right? Since x is last, this is your vertical. So these were the strips that were drawn through this region. This was the problem that was given to me. But is this the most efficient way to do the problem, or even any way to do the problem? Right? When I look at that inside there, integrating here with respect to y is a little bit of a problem. What if I switch the order of integration? And that's what today is. When you are given a problem, which is what we did before, is we kind of made the choice, but maybe you are given a multiple integral. A question you need to ask yourself is, should I switch the order of integration? And as long as you switch the order of integration here and here, you're legal. So sometimes the problem will prompt you, evaluate by switching the order of integration, but sometimes it won't always prompt you, and then you just have to recognize, oh, I don't think I can integrate this, should I switch the limits of integration and have things work out better? So again, I'm going to draw my domain area. Because remember, this is y equals x, y equals 1, from x equals 0 to x equals 1. And again, with x being last, that was a vertical strip. What if I don't want to draw a vertical strip? Look at what I did there. I'm going to integrate sine y squared, but with respect to x, which means what's the y stuff? Boo! It's a constant. All of a sudden, this is a constant, right? As soon as I change this to dx, this value for the first integration becomes a constant. But look at what I had to do to the limits of integration. dy is now on the outside, which means these have to be y numbers. Do you see where they came from? But since x is on the inside, what are the inside limits? X equals 0 and x equals y. Which of course is the same as y equals x, right? And then I go from y equals 1 to y equals 0. So I have the same freaking shape, the same domain region, but what's my strip now? Because y is on the outside, I have horizontal strips. But it's the same region. So now let's go about and integrate this. Right? See what I did there? Just doing the inside. Since this is a constant, integrate a constant with respect to x. That's x times the constant. But I'm going to evaluate that at x equals y and x equals 0. So if I put in y, I get y times sine y squared. And then I get 0 times sine y squared, which of course makes the second part go away. And now, boom, beauty, look at what I had, right? You were kind of probably wondering why I went through that u substitution, right, on that first slide. So integrating this turns into, using u substitution, 1/2 times negative cosine, so I'm going to flip my negative out here, of u, which is y squared, evaluated at 0 and 1. So that's negative 1/2 times cosine of 1 squared, which is cosine of 1, minus cosine of 0 squared, which is cosine of 0, which is 1, and whatever that number is. Right? So had I not, I would have wasted an awful lot of time desperately trying to integrate sine y squared dy. Don't even know what I would do. Honestly, don't know. Let's do another example. Notice the directions tell you to reverse the order of integration. You might want to pause and take a minute and say, what if I had tried to integrate this without? What would happen? But step 1, you don't have to do this, but I like to think about my domain area. So with x being last, that means the outside limits are x numbers. And with y being on the inside, these were y numbers, or y functions, excuse me. So when I draw that domain, I have y equals x squared, and y equals 9. With x on the outside, we were drawing vertical strips. I want to reverse the order of integration, which means I want the exact same region, not changing the domain region, but I want to draw horizontal strips. To do that, reverse the order of integration, which means you have dx, then dy. You have your surface. But what are your limits of integration now? Y is on the outside. So you're going to go from 0 to 9. And then what about the inside? Since x is in the middle, I need two x functions. What's that going to be? X equals 0, right? And then what is this? X equals, square root of y. Getting my way. So now it's down to problems from the last couple of videos, right? I'm going to integrate my surface with respect to x, which means this is a constant. So I have 1/4 x to the 4th e to the y cubed. In place of x, I'm going to put y to the 1/2. So I end up with y squared, e to the y cubed, and I hope you already see something good happening, right? And then in place of x, then minus 0 to the 4th. So this goes away. Now go back out because all I did was take care of the inside integral. Now I'm going to say 0 to 9. I'm going to osmosis the 1/4 out. Y squared e to the y cubed d who? dy. Ooh, that doesn't look like E2, that does it? So, and again, I hope this Calc 1 part goes for you fairly quickly. Who'd I forget? Yep. Osmosis that 1/3 out there. So I end up with 1/12 e to the y cubed, evaluated at 0 and 9. So that's 1/12 times e to the 9 cubed minus 1, whatever that is. Yes, you could just leave it like that without a calculator. Let's do one more. Oh, there's the picture of the place, of the domain. Let's do this one. So again, you might want to pause this. and see if you can do this yourself. But or think about why you wouldn't be able to do this, right? Or why it would be difficult the way it is. Again, I might not tell you to reverse. You might have to think of that on your own. Here is my shape, right? Since dx is on the inside, this is x equals and x equals, y equals, y equals. And draw x equals 1 and x equals root y. And y goes from 0 to 1. And with y being on the outside, originally they were talking about doing horizontal strips, right? I am suggesting that you reverse that order. So instead of doing dx dy, do dy dx, which means instead you are doing vertical strips. And again, my boundary doesn't change, right? That was a big deal we talked about when we were deciding the order of integration. This time we are given an order and we've decided to switch it. So what would my x numbers? X numbers need to go on the outside. So I hope you can see that the x numbers would be 0 to 1. But what would my y functions be? Right, top to bottom. Y equals 0. And what's this? Yeah, it's y equals x squared. Now, since I am integrating the inside here, with respect to y, though, this whole thing is a constant. So when I integrate that, I have the constant times y to the first over 1. And I'm going to evaluate that at y equals 0 and y equals x squared. And notice what happens. Something nice, right? I get x cubed plus 1 times the 1 to the 1/2. But what are you replacing y with? Oh, snap. Isn't that nice? Then, of course, you're also going to put in 0 for y, which means you're going to, it's going to be minus 0. So that goes away. And then you are going to integrate the outside piece. Dx, right, because the 0 part went away. And notice now again, you've got a very nice u substitution situation. So you are going to integrate 1/3 u to the 1/2 du. Integrating 1/2 to the is power up, divide by the power up. So it's going to be u to the what? 3/2 divided by 3/2, which means you're really multiplying by 2/3. And you're evaluating this at x equals 0 and x equals 1. One cubed is 1, plus 1 is 2, which is not an integer, right? The square root of 2 cubed, not an integer. Plus 1 minus, whoops, sorry. 1 plus 1 is 2 to the 3 halves, minus 0 cubed, which is 0 plus 1, which is 1 to the 3 halves, which is 1. And that's how I'm going to leave my answer. All right. So that's all for this one, right? So not too bad. Just practice really getting yourself to a situation where you can integrate like you did in the previous video, and then just recalling that you've got some use substitution problems, or how to practice doing your use substitution problems. All right, I will see you in our live session.